Assalamualaikum warahmatullahi wabarakatuh. Good morning to our coordinator and fellow friends. My name is Iqbal Hadi bin Hamzah Rahman. My metric number is A18KA0040 from SKAB 3022 Section 1. Integrated Design Project 1, which is I studied in my degree third year. I will explain a little bit minor about my project, which is earthwork, erosion and sediment, water reticulation. Let's go to the earthwork part. Earthwork introduction. The initial phase in any construction activity in the development of a project is earthwork. Earthwork are engineering projects that involve moving or processing large amount of soil or rock on the Earth's surface. The process also includes site clearing, cutting and excavation, transport and moving, also compaction and sloping. The proposed level that has been determined at this stage will have an impact on the determination of road level, sewerage, gradient, and the other factors. The process of earthwork include excavation, grading, temporary shoring, cut and also fill, compaction, and lastly disposal. Scope of work. Determination of proposed platform level, cut and fill process by using grid method within the site boundary, cross section of the site plan after cut and fill work, slope stability analysis by using Bishop simplified method of slice, cut and fill by using grid method. The process is essential in designing the proposed area to cut costs and duration of the project. The differences between cut and fill volume calculated must be within the range 50% so that they will have no additional cost for importing soil. This is the step for our procedure by using grid method. Then after we calculate, we get the total of cut volume, total of fill volume, balance also percentage difference is 5.18%. Proposed level in earthwork analysis. Proposed level was determined by using the site existing topography. We can see our site part 1 and part 2. And cut and fill, the main objective of cut and fill excavation is to conserve mass as much as possible to maximize the use of existing material. The color which indicate blue for fill area and red for cut area. Slope stability. The potential of soil cover slope to withstand and undergo movement determined by stress calculation and assessment of a slope before the failure occur. We use the Bishop simplified method. The radius used is 16.225 meter, slope ratio 1 per 1.5. Our safety factor is 1.322, so that when our safety factor more than 1.3 is okay. Next, erosion and sedimentation. Erosion and sedimentation are natural process. This process occur daily on all land because of uncontrolled land disturbance, deforestation, and construction activity which exposed to wind, rainfall, and runoff. The purpose of erosion and sedimentation to control the flow of rainfall and to ensure the excavation work run smoothly. For design criteria, rainfall estimation, peak discharge estimation, and also temporary drainage design. It also includes erosion and sediment control design, sediment yield estimation, sediment basin, and others. For design criteria, firstly we design rainfall estimation with ARI equals to 2 year, time of concentration over land, flow time, channel flow time, and average rainfall intensity can be calculated. Second, peak discharge estimation. Divide our construction site into 4 catchment area. Area 1, Area 2, Area 3, and Area 4. For total area, our project is 41.29 hectare. Third, temporary drainage design. Q is calculated by using Banning equation with assumption Z equals to 2, so SO equals to 0.002 and N equals to 0.035. Then the trapezoidal base hydraulic section can be calculated. From the calculation, it can be concluded that the flows are subcritical flow and okay for the design. Erosion and sedimentation control design. The primary principle of erosion and sedimentation control recommended are minimizing soil erosion, preserving topsoil and other assets, access road and site management, runoff control and management, earthwork and erosion control, sediment prevention control, slope stabilization, site maintenance. Sediment and yield. Sediment yield is the amount of sediment expected at the end of the drainage point from design site. This estimation helps to predict the amount of sediment for sizing and maintenance of sediment control (BMPS). By assuming C equals to 0.5 and intensity of design storm 50 mm per hour, we can get Y. Sediment basin. A sediment basin consists of an impoundment, a dam, a rise pipe outlet, and an emergency spillway. For the design process, determination of type of sediment basin, determination of sediment basin, settling zone, sediment storage zone, overall basin dimension base, sizing of basin outlet, evaluation of trapping efficiency. Also, we have designed forward sediment basin according to the design criteria. And lastly, other more recommendation to cope with problem that may arise from erosion and sedimentation. Firstly, wash through, seal fence, seeding and planting, rock armor or gabion, also retaining wall. And lastly, for minor part is water reticulation. The water reticulation system is essentially the water distribution network, and once the water has been collected and cleaned, it must be delivered to the customer. System consists of a network of pumps, pipes, and water tanks that are designed to supply and distribute water to the domestic area. Components of water reticulation system that include storage tanks, type of pipes, type of joint, suction tank pump, domestic water meter, and firefighting meters, firefighting pipe, and fire hydrant. For first part, we explain pipe design. The analysis of reticulation pipeline in this project is done by using a Hadi cross method, or known as head balance method. Second, daily water demand. The water demand is determined based on 1 day storage, and it is based on the type of premise. The total demand we get 2,617 meter cube. Average and peak flow rate. Total average flow rates 20.285 liter per second, and our total peak flow rate 75.715 liter per second. Firefight flow rate. It used to determine pipe size and arrangement to deliver water to a specific area. It is important for emergency response to ensure that the total capacity of the system is enough in response to a fire. Our total fire flow rate is 53.119 liter per second. Lastly, for analysis, the residual pressure at any water fixture shall not be less than 2 meter head. All distribution pipe shall not be subjected to a pressure more than 30 meter head, so that 2 meter more than pressure and more than 30 meter. Storage tank design. Our total water demand we get 2,670 meter cube, and when we calculate our workable volume of water tank is 2,945 meter cube. Since our workable volume of water tank is more than total water demand, is okay. Top water level equals to 63.6 meter, and HB equals to 11.907 meter, more than 7.62 meter. Thank you.